Thank you, EduBridge, for organizing and providing such an impactful platform where we can just meet and share our experiences and talk about technology. Very frankly, when I started my career somewhere in 2004, we did not have such great platforms where we were able to exchange our ideas and all. So yeah, thank you, EduBridge. And thanks to EXL for nominating me and giving me this opportunity to represent the organization and share my thoughts and experiences around Java and related technology stack. So welcome all the participants, and since it is a masterclass of 2 hours, I think we have ample time to discuss about Java. We'll be discussing about the technology per se. So most of you, those who are just getting their feet slightly immersed in waters of Java, they might know the broader scope of this language. And then we'll just come to know about Java. So the topic today is very interesting, although it's pretty innocuous in the statement. It says code to decode career in Java, and the word to take away from the statement is career. We are not discussing out here any job. We are talking about career, and career is a very, you can say, serious ball game where we spent our entire life. So whatever decisions need to be taken out here need to be taken with informed knowledge. And I'm here to, you can say, share my experience, where I am today, what has the journey been like in Java world, what are the opportunities, and that's it. Okay, so agenda for today's session, definitely why Java is important, and that's what we will be just going through. Footprints in Java, we'll just go through what all areas, you can say what all domains Java is primarily being used, or you can say effectively being used. We'll just move to generic skills in Java, which is being required by all the programmers working in this stack. Career opportunities. When I talk about the career opportunities in Java, what I mean is you can say uh, uh, generic career opportunities, you knowing Java and all, and scope in cloud, AI, ML, and IoT. I have taken this separately because a lot of buzz is there around these three, you can say, areas. And let's take all these three areas separately, and how Java can contribute to your career in cloud, AI, ML, and IoT. Role-based skills in demand. When I say role-based skills, I would like to say based on your experience. For example, somebody is a junior developer, then what are those things in Java which will be required as compared to somebody who is pursuing career as a solution architect or an enterprise architect? Then definitely the skill set would differ a lot. Java versus Python. Why I have added this point is I think most of the time participants are interested to know when they are starting off their career whether they shall move to Python or Java or such other languages. So I know very well that this question would definitely be coming on my way. So I have taken it separately, and we'll be discussing about Java versus Python. And after that, we'll be taking question and answers. Uh, uh, right. Okay. So just taking a little bit of time just to introduce myself, although Pratibha gave a nice introduction. Thanks, Pratibha, for that. So I'm Navengit Yadav. I'm having 18 years of work experience. So right now I'm working with EXL Services based out of Noida. And right now my, you can say, current roles and responsibilities are I'm part of a product division to evangelize that product, giving thought leadership around that product, making the roadmap of the product, designing the product, and ensuring that all the releases are happening in time. And just, you can say, I'm also liaising up with various stakeholders around that product, mentoring my team, giving technical lectures, and ensuring we all are learning Java and keeping abreast with the latest technology trend in Java. So that is my current roles and responsibility. I would like to give you a brief background about you can say my career. So I started somewhere in 2004, and I think most of you are either starting your career in Java or starting your jobs or quite new to job. So I just started in 2004 as a, you can say, campus recruitee for one of the multinationals in NCR region in India. And like for most of us, your first project is very important and close to your heart, because most of the things which you learn throughout your career is that very project. Whatever trainings you go through the starting few months, that matters a lot. And I was fortunate enough to, you can say, and Java happened to me by chance, very frankly, because during those times, early 2000s, if you take up the MNC culture and all, what used to happen was students were put into batches of Java, mainframes, and .NET and QA. These, you can say, these happen to be, you can say, four streams. And I was, you can say, a fortunate one to get into Java, and that's how I started journey with Java. It happened by chance, but definitely I think luck by chance happens. So okay, so in my first project, I got to work in frameworks such as struts 2. That was, you can say, the in thing in Java around that time. It was Java 1.4 I started my career in, and from the database side it was Oracle. And believe me, I knew, uh, I was very confident when I just landed up with that project. I thought I would be able to do great work out there. Then I realized that professional Java, writing code, is a very different ballgame altogether as compared to what we used to do during our engineering days. We used to create programs such as Hello World and few small projects. Uh, Although working in an enterprise way in a professional Java world, things were very different. I did not know about, you can say, what is a request response, web server, client tier architecture. A lot of things were there. I was just typing code, and I wasn't writing code. I was just converting something which my technical lead gave it to me, and I was just converting it based on, you can say, whatever I knew at that time in Java. So that project gave me an insight about a lot of things. It was about, the first thing was knowing the concepts in Java. And believe me, when I talk about knowing the concepts, it is something not limited to Java. This is for any programming language. And those are algorithms, which we learned during our engineering days. Around that time, we used to cram them, and we used just to pass papers and all. But yeah, very significant importance I got to know about algorithms, their big O notation, which we generally talk about, their time space complexity, which we have worked during our engineering days. I just got to see all these things happening around me. Data structures is definitely an area where I understood, yeah, without data structures knowledge, I'll not be able to do justice to my career in Java. And definitely database. Database was one thing. I still remember whatever queries, how to create queries, how to create an optimized query. I learned during my initial few years. I'm still reaping benefit of those concepts till date, and that is helping me tremendously. So the starting point of your career is definitely, I would say, a defining moment for most of us. I'm not saying for every one of us, for most of us, because that really gives us, uh, I would say, very that either inclination towards coding, or if I'm not having the right project with me, or not having the right people around me who are able to hold our hands, able to guide us, and probably people even start losing interest in coding and programming, and then probably that is not the right thing. So yeah, that was my initial few years that really defined the moment. After that, I just moved to healthcare domain, and there I got to engage myself with, you can say, great minds in that project in healthcare domain. I got to travel the entire globe and got to meet a lot of technical minds. I was able to learn a lot of J2E concepts, a lot of domain knowledge of payer, provider, and patients in healthcare, HL7 concepts of healthcare and all. So got to learn a lot of things out there. Eventually moved to the hospitality domain, and worked for Words, I think one of the most leading hospitality chains in the world. Worked with some terrific architects, then got to know about what is solution architecting all about, what is enterprise architecting all about. Was able got an opportunity to get my hands into the designing of code and all, and believe me, that was a very different experience from coding. That is an experience which only comes when you are doing a lot of coding and all, and you eventually get into the designing part of the project. That's what I did in the hospitality domain. Worked a lot of on, you can say, cutting edge technologies in Java, the enterprise solution like Spring, Hibernate, a lot of mobile application development I did. Eventually moved to French multinational later and worked for, you can say, a lot of work I did in Angular. And such, you can say, at the UI side as well. Since being a developer, I just did not want myself to limit to only Java, and because Java is not limited in itself, it is primarily a language which gets integrated with a lot of things. It could be database, it could be UI, it could be some third-party APIs and all. So that's how I just started working on a number of things. Got an opportunity to work in cloud in this project. And finally, I'm in EXL, as already told by Pratibha about my, you can say, introduction. So that's what I am in the nutshell of 18 years of work. Started off with Java as very basic, as just a type, you can say, somebody was typing code in Java, not writing code in Java. And eventually, this is my 18 years of work in Java. Okay, so that was about me. Now a disclaimer from my side coming, that definitely I'll be biased towards Java in most of the discussion points today, since that's what I know. You can say mostly that's what I know. Although I would like to be as objective as I could be with your questions, trying to answer them in a very neutral manner. But yeah, this disclaimer I just wanted to put across all of you. Before we start, since it's 2 hours, you can say, discussion, we'll have a lot of, we'll be taking pit stops and revisiting a couple of things which is not related to Java. It would be around programming and all. So programming is thinking and not not typing. And why I just wanted to mention this point is, since when I told you about my career journey, you might have understood that, yeah, knowing how to write hello world, how to create a class, how to create an interface is not the only thing. That is, believe me, the easiest part of a career in any programming language for that matter. Whenever we are starting a project and all, most of the time we start, or rather the all of the time we start with a requirement analysis. What we are going to make, what is a business lead, everything starts from business idea, right? And then this business idea, you can say, gets mapped to a high level technical design. Then it is mapped to a low level technical design. Then you can say we start developing components, and then eventually programming comes into picture of writing those components into Java or any other languages you can think of writing. So programming, you can say, it's all about thought process. Just and just knowing couple of syntaxes, it doesn't help. So that is the thought process of communicating with you what programming is all about. You should have an attitude towards programming. You can say a problem solving things should be there in your approach. And if you try giving interviews for organizations different, so all the good organizations, they rate you on your problem solving skills, your attitude towards anything, the problem which is given to you. A lot of puzzles are being given to you more as compared to your technical skills. And that's what we do whenever we are into any, you can say, interview sessions. If somebody is not able to write the code properly, that is, you can say, not the only point. It is all about the approach that the person is taking, the algorithms, the thought process, the idea that person is having. And programming language is just, you can say, an accelerator to that, and nothing beyond that. Okay, so on that note, let's come to the point. We'll just quickly read about why Java is important in the current domain. And definitely, if I talk about it, is beginner friendly. When I talk about beginner friendly, it's very easy to comprehend Java. Whenever we are writing, it's a high level language, and we can write the code very close to English language. In C and C++, those who have seen in the earlier days, it was, you can say, used to have pointers. A lot of technical jargons were there in, you can say, C++, and Java actually, you can say that alleviated a lot of such pains in other programming languages, and this is definitely a beginner friendly. uh, why it is beginner friendly is another thing. A lot of support is there available, you can say, in open market for Java. So hence definitely it is an easy thing to start. You do not have to purchase any license. Just go to the internet, download your Java latest version, and you are good to go in Java. So definitely it is very easy to start your thing. You do not need to uh, have very heavy duty machines or any of your personal laptops. You can start learning Java very fast. Updated features. So this is a point where Java used to lack previously. And if I talk about, Java started somewhere around 1995, and around that time till 2018, whenever a new version of Java was released, it was just happening around every 3 to 4 years. A lot of, you can say, big bang releases were happening in Java. If you remember from Java, I think 1.2 to Java 5 when it came in, a lot of new came in, like generics came in, support for concurrency came in. Such big bang releases were happening, and the developers were feeling the pain of it, because a lot of things were there for a Java developer to understand, and whatever new has happened. And that started drifting people from Java to other languages as well. And Python is definitely, you can say, one of the languages where people have moved. And eventually what started happening in 2018, I think 2018 June onwards, what was decided that features of Java would be coming every 6 months, and those features would be called as a release called OpenJDK. We have we know the term called SDK. That is, you can, the standard development kit of Java that we have. Every 6 month, the incremental releases would be coming with features, and every 3 years, Java would be coming out with LTS version, calling the long-term support of that version. So that was a big, you can say, a ball game. It changed the game for Java a lot. A lot of new features started coming in Java. Java also started competing with its competitors in terms of functional programming concepts, in terms of providing a lot of new features in Java. Even the concept of garbage collection and all got tremendously, you can say, effective in Java. And right now, on just a week before, on March 2022, today's 29th, right? Uh, Java 18 was released with a lot of features, I was just looking at few videos, the way the switch statement works and all. It has changed a lot in Java 18. So yeah, it gives all the developers a kick to be abreast with the latest trends in Java. And if we, after almost 20 years of Java into existence, if we are having this discussion about career in Java, that speaks about the language itself, how much relevant it is in current market trends, right? So when we talk about updated features, I have this slide. So this is how the release cycle of Java has become eventually. So if you see, starting from Java 8, you see a lot of releases are happening very frequently: 12, 13, 14, 15, 16, 9. You see the March and September. So the release of Java has become very frequent with the new, you can say, new features and everything which is happening in market. And if you see March 2022, which is Java 18, so it got released on it got released September, oh sorry, March 22nd it released. So yeah, a lot of new features are coming. If we talk about the updated features, code portability and security, why Java came into existence was definitely every language for that matter, whether it is Python or it is Java or C++, they come into existence because of some philosophy. And code portability, that means you write it once and you run it anywhere. That was a philosophy of Java initially, that whatever we are writing .java classes, we'll just create a .class file, and this class file we'll be able to run it whether it is a Linux platform, Ubuntu platform, Windows platform, even in cloud platform, whatever you think of. All the files would run without having, you can say, any issue. So that is the beauty of code portability. And because of this code portability, you can see Java being used in n number of things. I'll come to it in detail when we talk about AI, ML, IoT, and you can say big data sort of things, how Java is beautifully used and how you can create a career in those lines as well. Open source library support. You, whenever are stuck with any problem in Java, Google comes to our rescue. We are able to write anything, and we just do get beautiful solutions in, you can say, Stack Overflow or such, you can say, forums. Because most of the problems that we start facing in Java, people, since it is an language which is in market for I think more than it was developed 95 somewhere, those problems are already looked into. People have a strong community, a lot of libraries. Guava, Google Guava is there, Apache open source libraries are there. uh, we have artifact libraries in Maven, and Gradle is there. You just all the, you can say, APIs are available for you to start a project in Java. So yep, it's a rich set of open set source of library. This is a very important feature in Java. Java Enterprise Edition and API. Most of the big organizations, they just don't want to choose a language because of its popularity. It is always looked from the perspective of end-to-end, you can say, development model of a language. How stable a language is, how much backward compatible a language becomes whenever a new release for such languages come in. What is a community support? uh, what is the scalability of a product which is being developed? Right, what is the availability of an application which is being developed at an enterprise level? How much fault tolerant is my application? Is such things also play a very major role at an enterprise level. And Java is primarily a language which is being developed to address all such integration things, whether we have, you can say, servers like JBoss, WebLogic, WebSphere, Tomcat, Jetty, Netty, all these servers, they are able to comprehend and integrate with Java very well. And that's why the enterprise edition of Java and the API with which it integrates with the rest of the technologies, it's awesome. So that is one of the compelling reasons of choosing Java in corporates and organizations. And yep, it has a great support. We have already talked about the rich community support like Stack Overflow and you can similar forums. A lot of things are there where you can definitely get a lot of support in Java. Wide range of development tools. I think in today's world, we all need some integrated development environment to start developing our code. We can't just write our code in Notepad and do a very, you can say, Stone Age style of a development. A lot of such, you can say, development platforms are there, tools are there. Eclipse, we have IntelliJ, IDEA is there, we have NetBeans, right? So all such, you can say, very advanced level of integrated development environments are there, which leverages Java very well, and you can come out with a solution in no time. And for that matter, if you want to develop a web application using Java, we have a framework called Spring. Spring Boot is there in market. Believe me, it takes less than a minute to be up and ready with your API using Spring Boot, and you're good to go. You can host that application and people can start consuming it less than a minute. So that is what the wide range of development tools are present whenever we are working in Java. Enormous set of applications dependent on Java. As I gave you an introduction of myself, I have worked in finance, I have worked in hospitality, healthcare, and now I'm working in insurance. I think there is no domain where Java is not leveraged. every other domain, even the project in NASA, they use something called Java FX for visualization. And I'll be just coming to that slide when we are talking about penetration of Java in AI and ML algorithms. You can say projects in NASA's and for real-time capturing of data, such things are being used. So, yeah, high demand. Definitely, when we have so much of things associated with Java and corporates are using Java day in and day out, resources are in high demand in Java. And believe me, I'll tell you out of my experience what is happening in past 1 year. Uh, you can say pre-COVID times and post-COVID times, things have changed dramatically in the world of Java. The demand for Java has risen many folds, rather exponential in this domain. A lot of projects are coming in Java, because in Java we can do an MVP sort of a thing quickly. A lot of such tools are in market where we can just write our code quickly, show it to the market. So demand for great Java resources are there, and believe me, we are not able to get good resources in Java lately. And salary wise as well, believe me, if I compare what I started getting initially, uh, multiplier of 3 to 4 times have happened in that thing. And truly it is a high paying job. A lot of, you can say, opportunities are there in career wise, and we'll be coming to all these things in our discussion today. Dominant against allies. When I talk about dominant against allies, I do not want to undermine other languages as well. Every language has their own, you can say, philosophy of being developed, and they are strong in their own areas. All the languages are lions and the sharks in their own domain, and definitely other languages are. But yeah, Java, it does have its own, you can say, you can say, a flag position there, and definitely it's a dominant language. Okay, if I talk about the popularity of Java, if these are two standard indices which we call about TOB index, and PYPL is called popularity of a programming language. Python is definitely a language which is, you can say, coming along very well. A lot of, you can say, programming is being done in Python. Although I would say Java is also considering Java to be an, you can say, old horse. It is still there, galloping very well, and it is not a dead one. And you can see it to be amongst top 4 languages still. And we'll be coming to Java and Python somewhere towards the end of the session, and we'll talk more about it. Okay. Uh, Talking about Java footprints, where Java is used, I think there is no domain or no application where we do not use Java per se, but definitely let me give you some idea about those domains, or just you can say where we're using Java very well. In mobile applications, we use Java very well, like in Android, the Android-based applications, they use Java. The JVM which is used with Android is, you can say, highly compatible working with a Java based. It's the JVM. Although we use a lot of other JVM based languages, such as Kotlin is also taking a lot of traction in mobile applications. But definitely Java is a language to be considered out here. And one of the differences with Python is that Python is not making inroads in mobile application. It has its own, you can say, strong areas where Python is used, that is data science and machine learning and all. So in mobile application, if somebody wants to make a career, Java is definitely in the reckoning. Talking about desktop GUI application, yes, we have ultimate visualization tools in Java. It could be Java FX, it could be Swings, it could be the legacy AWT we used to work. Definitely Java is there. Talking about web-based application, I think in my 18 years of WorkX, I just started, as I told you, working on Struts framework initially. And the way Java has evolved with the, you can say, new frameworks, whether it is an ORM in Hibernate or it is Spring MVC, it could be JSF, There are a lot of such frameworks are there where Java is very much in use. And for example, Spring Boot is one of the frameworks where you can develop your application in less than a minute. And believe me, if I say 1 minute, it could be even 30 seconds, but it won't be more than 1 minute. And it has become a lot easier developing in Java. So a lot of web applications, or you can say the enterprise web applications, the leading hospitality, you can chain, or the which I was working earlier, it was using Java, and it was taking, there were performance wise, absolutely brilliant performance of that application, the way we were using Java. So yeah, the web-based applications, it is in the reckoning. Cloud-based applications, definitely. Today, all of us, we know as developers, or even we are on the producer side of the code or on the consumer side of the code, we can't live without cloud-based application. And this is, and post-COVID era, we all know that yeah, it's better not to host all the infrastructure with us. With all the startups coming, you can say a cloud is here to stay, and this is the reality of the world. We have to move in cloud. So Java gives very good APIs. It gives, for example, AWS provide SDK with which we can integrate with a lot of cloud providing services are there. We can host our application in cloud very well, and I'll be coming to this point whenever we are discussing careers based out of cloud. So yeah, enterprise application, most of the applications big corporates are developing. I do not need, sorry about that, need to go into the details of the enterprise gaming application. Java is pretty effective, like Minecraft application is using Java. A lot of, you can say, programs are being written in Java. In gaming applications, it is being used. Scientific applications like MATLAB is one of the applications. You can say, I think it stands for Matrix Laboratory. A lot of mathematical computations are happening, linear algebra based, strong computations, such things are happening in scientific applications of MATLAB. You can say image processing things are happening, and Java is being used because of its performant nature. Big data technologies is another area, and we just seen a couple of slides like everything is big data. Whatever data we are working on, or whatever technology is being used to analyze that data, whether it is Hadoop or it is Spark, it could be Cassandra. Such, you can say, technologies which we are using in big data is primarily either they are written in Java or they are for JVM. So definitely Java is used everywhere. That is in the nutshell. Okay, so I would rather say that it was like the first segment of our discussion today, where we talked about why Java is important to us, what are the footprints of Java, about the background of what are the features Java, why, and that really makes it a language where we should be seriously thinking of a career in Java. What we will be discussing in this segment upcoming is primarily focused on the career areas, and which is, you can say, the defining theme of our discussion today. Before we just get into that segment, again, we have reached a pit stop, and I would like to, you can say, bring about this statement. I think all of you can see that. Bad programmers worry about the code. Good programmers worry about data structures and their relationship. So that is a philosophy of programming. Whenever we start with a program, the skills which are required, the skills are just not going through the entire book of Java overnight and giving a paper and getting a certification. And it is basically an art in itself. You need to hone your skills in writing programs. You need to give thought process of it. There are a lot of design principles in Java, which I'll be talking about when I talk about the skill sets in Java. So always believe in this philosophy. You don't be in a hurry against Java or Python, which can give you more money. Believe in the philosophy of excellence and not success, as was beautifully said in the movie Three Idiots. So Java is also, you can say, following that principle. Okay, this is a very important slide of discussion today. And if I talk about the skills in Java which are required, when I talk about these skills in Java, these are a must to have skills for any Java developer, with whether that developer is a novice or that person is having whatever number of experience. Without these skills in Java, probably it's very hard to survive. And these, believe me, these are the minimalistic, I would say, skills in Java to be a good programmer, or somebody who's able to turn things around. Just by knowing a couple of syntax, it won't do. So let's start with core Java skill sets. And if like OOPS, the concept of polymorphism, like encapsulation, abstraction, all such concepts are very important. And Java being an object-oriented language, it really helps us to see all these things happening around us. Whether you see an example of a car or even of a lift around you, a lot of such things, object-oriented things come into practice. So it is very important to know all these concepts very well. Why we are using encapsulation, why the data and the related functions are together. That is one of the critical features provided in Java. Concept of polymorphism becomes, you can say, one of the defining philosophy of core Java. And when we comes to a lot of things in Java, we always code to the uh, you can say generic things, and we just try writing the specialized courses behind the scene, which we called abstraction. So these concepts are very important to practice. I won't say learn. These are the very important skills. While you are practicing your code, you should be knowing it very well. Coming to something called design patterns. This is a very critical part of Java. When you start knowing any language, you tend to understand or get to know about the how it is written, the syntaxes of that particular language, how to write hello world in that language, and then you start evolving. So when you get a bit comfortable in knowing the you can say syntaxes, design patterns, whether it is Java or any other language, if you're working on, it is very important. How to write the correct code, it teaches us. For example, there are creational design patterns. Even if we are writing student ABC is equal to new student, it takes memory on the heap in Java. What is a best practice of creating a Java object, whether it should be created on a heap, or how we can reuse a particular class, such things. Because most of the time, if you are a newer developer, you might have seen like a memory out of bound exception or array index out of bound exception. It does come. The reason of coming such exceptions is we aren't utilizing, or we do not understand the design patterns. We are not using beautifully the design patterns. Of creational design patterns are there, it's behavior design patterns are there. For example, how various classes should be interacting with each other. Whenever problem statement is given to me, shall I go into the composition design pattern, or shall I go into the polymorphism or the inheritance based the design pattern shall I go? So such things, you can, the behavior one are there, creational design patterns are there. Then we have design patterns which are called J2EE design patterns are there, because most of the time we try developing applications or solutions which are n-tier based solutions developed on servers. So we have J2E design patterns out there. So we should be knowing the design patterns very well. And that is, you can say, whenever you are trying to eye for a senior role in Java, it could be a tech lead onward, solution architect, design architect, or enterprise architect. I think this is a must to have knowledge to have, and it really helps even an organization for which you are developing the code, and also for your growth as well, because your code would not be coming back with issues and all, and you'll be able to apply the right design pattern. Coming to data structures, once again, without data structures, you can't survive programming. And data structures are more or less same, whether you write data structures in JavaScript whether you write data structures in Python or you write data structures in Java, the philosophy remains the same, because it teaches us not the programming language, it teaches us you can say the domain thing, how to organize data, how performant my solution can become by choosing the right data structures. Even if I have to write a for loop, I need I need to store certain data. I should not casually go and use a hash map. I can be thinking about using a linked list, or I should be using a tree set. It could be graph. It could be any other thing. So knowledge of having the right data structures is very important to make our solution performant. And if you are not choosing the right data structures, believe me, your solution is bound to fail whenever it goes into any production environment. Because in production environment, what happens is a lot of multi-threading comes into picture. The how your code is performing, that gets tested thoroughly. So choosing the right data structure is also very important. So yep, this is one of the critical skills of core Java that you must be knowing. Multi-threading, and one of the nemesis I would call for most of us is multi-threading. Believe me, well, I was on the other side of the table giving interviews, or I'm the other side of the table taking interviews. People do fret by the word of multi-threading. This is a difficult subject in core Java as compared to other parts. Although this is a very pertinent, you can say, uh, from Java perspective, because concurrency is one of the critical features of Java. That's why Java is being used in a lot of such applications. How to use multi-threading in the correct way, knowing what synchronization is all about, what is volatile keyword is all about, it's pretty easy. Putting it into practice is something which you should strive forward to. Always, whenever you are writing code, think very deeply how this code's gonna behave in a production environment, and will this code be part of any, you can say, concurrent programming. So from Java 1.5, very good APIs with Java concurrency got introduced that really alleviates a lot of boilerplate code, and it gives you very good solutions written around concurrency. So yeah, these are very important skills to have in Java. ORM. Uh, ORM basically is object relational mapping. And when I talk about ORM, it is with the Java and database connectivity. Most of the times, people who write code in Java, they are good with their area. However, they, you can say, lack in the database word. That has been a challenge till the time ORM came into existence. And what ARM solves for us is whatever class you have written, uh, it maps your class to a database table, and whatever constraints you are applying in your class, it would create those constraints for you. So it really that solves that purpose of a Java developer, knowing the database tables, constraints, a foreign key, the composite key, the primary key, the sequences and such things. It alleviates uh, that knowledge of somebody going into the database side of the world, getting to know it. Although it definitely helps, because I have experienced that thing. Java is a language where you, just by knowing Java, you'll not be able to reach far in your career. You have to know a database, you have to know UI, you have to know servers. But yeah, ORM is definitely one of those things. Whenever you are designing solutions or approaching a solution development, it is very important to know that aspect. What is JPA? JPA is a specification provided by Java that is called JVA Persistence API, that gives you like set of certain very standard specifications are there. Java says this is how you should approach writing your, you can say, vendor specific solutions of ORM. And vendor specific solution is like Hibernate is there. We have Eclipse Link is there, which is more of like object to table mapping things are there. We have a slightly different solutions like iBatis, Zook. These two solutions are more or less differ, you can say, based on table structures are there, we just you can say write all the queries in a different mapper files. So the philosophy of Hibernate is slightly different from iBatis and Zook. But eventually what happens is you map a class to a table. So our knowledge of ORM is very important. Spring Data JPA is another beautiful written wrapper around JPA, which alleviates a lot of pain of writing queries, and behind the scene it writes a lot of boilerplate code for you. You just need to write few method names like find by ID, find by customer name, and it generates all those queries for you. So working in you can say ORM sites becomes really very easy if you are using frameworks since that's Spring Data JPA, and it's a good skill to have. I won't say a mandatory skill to have, but yeah, knowledge of JPA Hibernate would help you to develop solutions end to end. Coming to the third point, which is Java build tools, I think Maven and Gradle. In today's world, I can't just write my code in my personal laptop in my Eclipse and I'm good. No, that doesn't happen. That is only good as far as I'm writing a college project or such things. We need to have few tools, build tool, which can basically scan your code, gives even the vulnerabilities which are present in your code. It builds your code, creates a jar or a war files, runs the entire test suite, and deploy your code into production or any you can say environment where you need to run that code. So we have you can say such build tools are available. Beautiful tools like Maven is there and Gradle is there. These are two most of the time they are being used. Earlier we used to have you can say tools such as Ant is there where we used to write a lot of scripts, but over the period of time these you can say a lot of evolution has come. We use Maven, we use Gradle. So knowledge of these tools is must to have for writing code whenever you are considering a career in Java. Believe me, few questions around build tools are must to have, and knowing them would really make your chances bright for any organization. Not knowing Maven or Gradle would give an impact to a person who is interviewing you that you have learned Java just as a side subject. You haven't worked in Java in a professional environment. You should be knowing one of the two tools, believe me, or any related such tools which are there in market. Web technologies is something which is good to have. When I talk about web technologies, it is like expanding your horizon from Java to the integrating things like CSS, HTML, jQuery, and JavaScript. And the idea of adding these points is I have seen most of the Java developers struggling with JavaScript. What happens is that, believe me, I'm just talking my heart out here. People, any Java developer takes JavaScript for granted. He or she thinks the word Java is written to it. So I'm just writing in my resume, I know JavaScript. Although the philosophy of JavaScript is very different from Java, right? They are way different, right? And I have seen people knowing Java well, they are struggling in JavaScript whenever they are given an opportunity to debug a code even in JavaScript or to write code in JavaScript. Believe me, knowing JavaScript would definitely add wings to your career, because a lot of frameworks like Angular, or you can say for that matter, even if you talk about Node.js, a lot of things are being developed. The backbone, or you can say the underlying code, is JavaScript only. Even we talk about something called TypeScript, which is more object oriented JavaScript. That is, everything is written in JavaScript. So I personally say knowing JavaScript is very important because most of the time when you are going for a career, you'll not be constrained to writing few Java classes. You have to be full stack. It could be a MERN based like MERN, or it could be a mean based. So the R and A in both these stand for either React or Angular, right? And all these are JavaScript based. Eventually, they are JavaScript based frameworks. So you should be knowing something in web technologies as well if you want to take your career to take a giant leap. Coming to the Java frameworks, without framework, I think eventually we'll be reinventing the wheel whenever we are writing any code. We have to use frameworks in our lives, and we should be knowing the philosophies of these frameworks. For example, in our my latest project, I'm using Spring Boot. I don't know if I'll not be using Spring Boot and trying to write every other class by myself. It's going to take years to write those things right from scratch, when I can use all these things off the shelf, can integrate my code very well with my code. So Java frameworks, it is a very important concept to know frameworks, what MVC is all about. Whenever we are developing any web application, the concept of model view and controller, it is for us, it is must to be knowing such concepts. And just to give you an idea, in my very first project, like in 2004, I couldn't understand what MVNC stands for, what exactly they do, what is a model. Okay, I was able to understand only the view part. View means I'm seeing something on my screen. What is controller? Everything was going above my head. uh, Now we have all these lovely platforms like EduBridge, and such discussions are happening where you can say our horizon of thinking is, you can say, rapidly increasing, and we are getting to know much ahead in time that such things do exist, and we should be practicing or adding it to our skill set. Without knowing the concept of MVC, it would be very difficult for us to be, you can say, able to contribute effectively in solutioning side of projects whenever we are working on it. So yeah, MVC is another area. So hence, knowing frameworks is very important. I'm not saying you should be knowing every framework. You should be knowing one framework in one of the areas. It could be MVC, it could be JSF, or it could be struts. You should be knowing the standard flow of a request response, how things happen. Like Spring Security is there now. After having a framework on security, it really helps us, because nowadays we know if we try to access a website, uh, there is a concept of OAuth, OpenID Connect are there. SAML2, you can say, federation mechanisms are there. There are n number of things in market right now. If you try to log in a website, it gives you, okay, you can log in using your Facebook ID or your Twitter ID. So a lot of things are there in security, you can say, paradigm. Spring Security, by knowing one of the frameworks, at least I know how things work. So a framework, you do not have to cram a framework. Framework basically gives you the underlying philosophy of approaching a problem statement, even if you're not having that framework in that particular organization or in that project. But by knowing that philosophy of a framework, you can approach a problem statement better. Hence, try to explore more frameworks in your free time, and if you want to make an effective career in Java. Application containers. When I talk about application containers, the concept of servers, what is you can say an application server. We have few web servers are there. How a web server is different from an application server. When I'm developing any web application, a lot of thought process, basically it goes into not putting everything in application server. Load balancing your application is very important. Keeping all the static content in a web server so that the caching becomes fast, and all your business logic would be residing in an application server. So whenever we are developing solutions, we should be knowing the concept of these application servers very well. Then only we'll be able to develop an effective solutions. So these are different flavors of application servers. The philosophy remains the same: keeping application servers separate, keeping the web servers separate, the communication between these servers. It could be like how to add a caching layer between these servers, keeping all my static content there, load balancing my servers, how my app server is communicating with my database servers. So hence we should be knowing application servers or web servers very well if you want to make an effective end-to-end solutions. So that's how application containers we should be knowing. Java testing tool. Okay, so talking about Java testing tool is a very important and pertinent area where every Java developer should spend a lot of time. I have seen developers, they write code, they come to me and say, hey, Navengit, I have written my code, my work is done, give me another assignment now. And when I start looking into the code and start reviewing the code, I see, or rather I do not see any JUnit being part of it. Not having written JUnit as part of a Java code, I undermine the capability of a developer as a professional, that you are not doing your work properly. Whatever I write, it should be thoroughly tested. That is a philosophy of programming language, and that's why the beautiful tools such as JUnit, TestNG, and Selenium. Selenium is primarily into like automation of our web browser and testing end to end by using a lot of BDDs frameworks are there. So JUnit, TestNG, one of the two is must to learn. So whatever, even for one line of code that you are writing, any piece of code, if you are writing, it should not go untested in your production environment. For such things, we have JUnits, TestNG, Selenium, which definitely makes a quality deliverable. And we, as a Java developers, must be knowing these Java testing tools. Coming to the Java Enterprise Edition component, servlets, Java Beans, although Java Beans are not very much used, concept of JSPs. JSPs is also not being used these days a lot. A lot of single page applications, frameworks such as Angular, React, Vue, Next.js. There are some beautiful UI frameworks have already come into the market. Although I won't say these are must to learn, but yeah, Java EE components. When I talk about the Enterprise Edition component, what I mean to say is that how a request comes to an web server. What is the concept of a session? What is a concept of an application scope of a variable? Such things, what exactly a servlet it does. Because whatever framework I'm getting into, whether I'm getting into Spring MVC or I'm getting into struts or I'm getting into Java server faces, everywhere the concept of request response, request body, response body, headers, cookies, such things, they come into existence because we are developing a web application. So knowledge of servlets, interceptors, filters, they give you this idea of you can say how to write code, where exactly my code should be residing, whether I should be writing my code in servlets, or whether shall I be using a controller class, whether I'll be writing a JDBC class. So knowing the different layers of programming in an enterprise components is very important, and that would really help you if you are looking for your skills, or to rather enhance your skills in Java. Code version tool, coming to Bitbucket, GitHub, and SVN. Another very important, you can say, part of Java delivery. Whenever we are writing code, what happens in a you can say a professional world, you get you can say an assignment number X, Y, and Z. A team member starts working on that assignments. You open your Eclipse IDE or IntelliJ IDE, you start coding. After writing the JUnit and everything, what you do is that you need to check in your code, right? You just can't keep that your code with you on your local machine. So there are earlier what used to happen, we used to happen SVN. This is a code versioning tool. At times we need to you can say revert back to a particular version of a code, or we need to compare some code. So such code versioning tool means maintaining all your code base. You are able to see the history of the code, everything which is happening. It is a must to learn one of the code version tools in your career. Bitbucket and GitHub, you can say these are some platforms where the code can reside in cloud based. And you should be knowing a lot about Git. They are very different way of working. So knowing Bitbucket or GitHub is very important. SVN is definitely also a good code version tool to start off with. IDE, which stands for Integrated Development Environment. I think without having the right set of ammunitions, you can't go into a war. And same applies with an IDE. You should be knowing one of the tools very well. Without having ammunitions, you can't fight a war. And as simple as said, you should be knowing how to use Eclipse. I have seen members joining the team, those who are coming new to the organizations, although they understand the fundamentals of Java very well, they know the design patterns. When it comes to writing code in Eclipse, The usability of that IDE, I have seen people struggling at times because they just know to open an editor and start writing the code, and that's it. They do not know how to use preferences, how to add plugins or to create plugins. There are n number of things you can do in your IDE. You can there is you can say just open Eclipse and see what all things you can study about IDE. And it is very important that we take things for granted in IDE. We don't read tutorials about IDE. It is more like, okay, I just know it. No, I have seen people struggling even after having 10 years of experience. They might not be knowing how well we can search in Eclipse. So definitely knowledge of IDE is something which I would reckon is must to have. So these are the skills in Java which we should be having before we embark upon a career in Java. Okay, so having told you about the skills in Java, uh, I would like to talk about career opportunities in Java that we are having, and this is one of the important slides which you people might be interested in. That me being spending almost 18 years and working as a developer with an organization, what are the different areas where you, after knowing Java, can contribute and make a career after knowing Java. So definitely Java developer is an area where we can flourish. We start as a Java developer, as in most of the organizations, there's a lot of demand for such developers. Eventually, when we grow in our career, we become a technical lead. After having 4 or 5 years of experience, we can get into a role of a technical lead. When we talk about a technical lead, that means you are well aware of, you can say, Java technology. You know how to code, how to use the integrated development environment. You know how to do a code review, and you are able to mentor other team members on these basic things. So definitely, you can grow into the shoes of a technical lead. DevOps engineer is definitely an area where I see a lot of potential somebody somebody growing into. Why I have put DevOps as a separate area? Because most of the time, I think it is a very different skill set away from a very conventional Java programming. Everyone can't run the same race and be, you can say, number one there. There are different type of races, although knowing Java, and everyone can perform in different areas. And DevOps engineer, I personally consider this to be an area somebody who knows Java programming well can flourish in this career a lot, because a lot of traction is happening, knowing the CI/CD concept, continuous integration and continuous development. That's what most of the organizations are following, this philosophy. What I mean by continuous integration and continuous development is whenever we are writing code and when we check in our code to any of our code repositories, uh, code compilation starts. From code compilation, you can say compilation of my code, all the test utilities are being written. All the test utilities, they run, they verify that whatever I have written is correct. A lot of you can say optimizations are being performed now on my code. Once everything is being tested, it is either a green flag or a red flag. Whether my code would be, you can say, taken to the next level or not, that is being decided. Once that happens, my code gets deployed to a QA environment. QA environment is basically an environment where all the testers, they do the testing. All these things, the steps which are happening, right from, you can say, compilation, right from running of the test utilities, these all these activities are being managed by a DevOps engineer. They write different scripts. They write all these scripts in uh, tools such as Jenkins is there, you can say Bamboo, Hudson. All these tools are there where a lot of coding needs to be done. The DevOps engineer, most of the times I have seen members getting it all wrong. They consider it to be some support activity of IT infrastructure management. Not at all. A lot of, you can say, a lot of emphasis is being given to DevOps engineer, and believe me, most of the time what happens is before any project is getting started, DevOps engineer is the person who is generally hired the first, because that person has to create the infrastructure, because whatever code would be getting checked in, that would be taken to various stages and taken to the production. So I consider this to be a very good career opportunity for Java developers. A lot of things are happening in DevOps engineer, whether it is cloud or any other things. A lot of tools are coming in market for DevOps engineer. Automation engineers, again, like I told you initially, for a Java developer, it is good to know about JUnits. Similarly, for an automation engineers, whenever they are writing build scripts or they are writing code, they write a lot of Java code. They integrate tools such as JUnit with their Selenium platforms. They try to write a lot of code, how to do a parallel execution of whatever is being written, to identify concurrent programming, you can say, issues which can come into a code which a programmer might not have taken into consideration while writing the code. So definitely automation engineer is a stream where Java developer can grow himself or herself in this stream. A lot in demand, because it requires some specialized skills in knowing about, you can say, we need to write code so that it is testing the performant, how performant is a code is, whether it is getting executed in particular time frame or not. A lot of such parallel executions, or the scope is myriads of, you can say, opportunities are there in automation engineering scope. Scrum Master, most, why I have just added this point of Scrum Master out here. Most of the time, we do get mistaken by the role of a Scrum Master. What we think is Scrum Master is some business administration, or somebody like a project manager who is just calling out people every morning and just asking about, okay, what are you doing today? And he writes somewhere in the notepad, and that is the end of the day for a Scrum Master. Believe me, it is a very specialized role. And why I have mentioned for a Java developer, because Scrum Master is primarily not a project manager, and that person is not a developer. This role is primarily somewhere lies in between. I have seen a successful Scrum Master is the one who is coming from a technical background, somebody who has worked on that area well, knows the business area of that project or that domain well. And then the role is primarily to interact with various stakeholders. It could be the business owner of that project, or it could be the infrastructure guys, it could be the networking guys, it could be programmers. So Scrum Master is a role which eventually get evolved. You being a developer, going to know the enterprise solutioning well, trying to understand how a solution can work. You have already worked with you can say, business functional guys. Now you are into the right platform to lead a team, to help people solve their issues by listening up with various teams, and you know how to contact with various teams and all, which a Java developer cannot do. Because if the problem statement are infrastructure related, if they are related to, you can say, some licensing issues, probably a Java developer might not be able to do it. And vice versa. If somebody is a project manager, and that project manager might not be able to understand the language of a Java developer, if a Java developer says, I'm going to take 2 days extra for a problem statement because of I need to write a JUnit, I need to write a concurrent solution. If a project manager is being made a Scrum Master, that person, believe me, would gonna make your life hell. That person would say, come what may, I need this code in 2 days, without understanding what uh, is the problem statement of a technical person. So Scrum Master is that role I see a Java developer growing into, right? Okay, coming into solution architect role, I think this is a very, you can say, challenging role, solution architect and enterprise architect. Uh, After you can say, evolving into a role of a Java developer, a technical lead, solution architect role comes into play when you have design solutions for, you can say, your various applications. This is a role when you will be asked to design a solution more. What would be my UI layer? What all technology stack will I be using on my UI? The debate could be like, shall I go with Angular or shall I go with React? As a solution architect, I need to choose a right solution for the right fitment of my problem statement. I can't simply go with my emotions that, okay, since I know Angular well, I should be using Angular. If I know Java well, I should be using Java. Now this role is simply you need to come out of that domain of Java. I need to think of a solution which is the right fitment. So when once you have already worked with Java, you know when you can utilize this language well, when you can use Python, or for that matter, Jython, or it could be any other language. Solution architect's role evolves eventually when you are designing a solution. It could be the application of Hibernate. It could be the application of simple JDBC templates. It could be the solution of writing Spring JPA, or it could be adding a caching layer. Such things, such critical, you can say, designing of solutions come within solution architect. And this is a great career opportunity with a lot of skills are being required. And if people can grow into this career or solution architect. Uh, then comes something called enterprise architect. And how it is different from a solution architect. Enterprise architect is a role where you are spending more of your time with how basically organizations end-to-end technology stack is about. For example, it could be the security policy for an organization of data on which you might be required to work. You might not be required to work on one single solution. You might be defining, okay, all my data should be well encrypted. It should not be kept in cloud. It should not be kept in a third party. I should have my own data centers. What should be the protocol in which data should be getting communicated? What should be the SSO mechanism, single sign-on way of communicating amongst various other application? You'll be thinking from an enterprise perspective solutioning rather than from a particular solution. So that's how I see various career opportunities growing, and we can make our career in all these. There could be a number of ways as well. These in today's fast track a startup culture, you can become the CTO of an organization within 2 years. I can see that fancy titles added to people since they can work in all these areas. Why not? So just don't think that this is just you can say a few, you can say very orthodox conventional Java career opportunities that you can work on. And next we can see about now we'll be coming to that segment. We'll be talking about Java and cloud computing opportunities, AI ML opportunities. And this is a segment like Java and cloud computing. Now cloud computing has become a buzz. Everyone wants to run after it. And definitely based on my experience, I think this is a paradigm shift for all the developers out here, whether you are working as a developer, or you are working as you are not into the active development, but you can't do away with cloud computing. Before talking about Java with cloud computing, just want to give you an idea about the service models in the cloud computing. What are these cloud computing service model? On the left hand side, you see on-premise, it's there. In a very conventional couple of years back, this is how things used to happen most of the times, that everything used to be on your data centers, which you used to call your application, your runtime, middleware, OS, virtualization servers, storage, everything. And you used to have a lot of teams out there which were managing all these things. A lot of cost people used to incur. Then probably came the concept of cloud computing. And the nutshell, cloud computing is all about, you can say, you are having these resources somewhere hosted in the internet. You are just consuming this service as a pay-as-you-go model, and you do not have to worry about installing any server with you, or installing any virtualization or hypervisor, storage, networking. You do not have to worry a lot about it. You just if you want to float your product you can do in 10 minutes. If you have it in your local machine, you can go ahead, buy some space in cloud, you're good to go. Then we have three service model in cloud. They are called infrastructure as a service. Then we have a platform as a service, and we have software as a service. So these are various, you can say, service models. Infrastructure as a service means you do not have to worry about, you can say, base servers. You just have to worry about operating systems, middleware, runtime, and applications. And Java developer, if I am a Java developer, what I can do is that if there is a code, for example, I'm working as a freelancer, right? And one of my challenges as a freelancer is just to test my application with the right set of, you can say, infrastructure or hardware, which I might not be having in my local, right? I can, for example, if I'm working in AWS, there is a, you can say, EC2, you can say compute cloud. I can take an instance of compute cloud or whatever hardware capacity I want. I can install my code out there completely, and I can test my code as a Java developer. And as a freelancer, I can go ahead and test all my infrastructure as a service thing out there. Coming to PaaS, like platform as a service, that is one of the very exciting models in cloud. Me as a Java developer might be required to create a solution where I need to store a couple of things. I might be required to use, you can say, a couple of simple queue service. My requirement is, okay, whenever I'm storing something to something in the server, a message should get generated and an email should get triggered, right? In order to write code for such services, I might be required to have a lot of boilerplate code in my local. I need to have to write a lot of such services. Now with having platform as a service, I can use SQS, SNS, simple email service. All these services are exposed to you through cloud vendors. Like as a Java developer, I consume my database by using JDBC code. I am provided with a lot of SDKs are there in Java, which consumes or integrate with all these services very well. And in a minute's time, you can write a very, you can say, flexible code without writing all these codes in your local end-to-end. Java provides these SDKs, the I think standard development kit, AWS provide, and you can integrate with your code and you are good to consume all these services, whether it can be an RDS, it can be SNS, it's simple queue service, email, storage, S3 buckets, a number of things. So yeah, in cloud computing as well, Java, uh, I think it's a great scope and a great career opportunity for people who are working in Java. We have, you can say, Amazon has its own open JDK flavor of Corretto. I think Corretto 11 or some version is there in Corretto. So yeah, it provides you with a lot of opportunities out there. Uh, Java and the JVM in the runtime of the cloud. Quickly go through this slide. If you see, Amazon Web Services is the leftmost, and blue is the Java one. And you can see Java is everywhere. Most of the applications which are running in cloud are Java and JVM based. So that is the intent of showing you the diagram. Okay, now comes a very exciting, you can say, opportunity of IoT. You might have seen a few advertisements where Amitabh Bachchan is sitting in an airport, and from there he is able to just manage his air condition, which is running somewhere in India, right? So Internet of Things is all about all the devices are connected, and believe me, most of the time we just find it to be like something out of the world is happening. What is IoT is all about? What do you mean by Internet of Things? Uh, the concept wise is pretty simple. You are having few devices which are interconnected, like like in our homes. I can manage my television, which is on Wi-Fi. I can just speak to it, and all such things are happening over internet. Java gives a very good platform for all the developers who are eyeing their career in IoT. Believe me, it's a very exciting platform. Even I have tried working on creating few solutions in this space out of curiosity. And this is a very exciting area. Since Java philosophy, as we initially discussed, is all about write once and run it everywhere. The concept of having that bytecode which can run in JVM beautifully, whatever platform you're using. That is one of the key features of developing IoT devices. And what one thing I just wanted to show you in this diagram is on the right hand side, if you see there is a circuit board. This is called Raspberry Pi. This is basically a single board computer system in itself. This is not a chip or something. This is a computer, right? You can connect a monitor in this computer. You just connect a keyboard in this computer. You're good to go, right? And earlier, when we did not have, you can say, elaborate desktops or such thing, this was a cheaper way of coding, and you can install Linux, Ubuntu, whatever things you want on this computer is called a Raspberry Pi. And if you see out there, there is a long black GPIO, which is called General Processing Input Output. I think these are pins. In this pin, you can add an LED, right? Uh, it's a simple LED, and we have a very beautiful API called Pi4j. Pi4j is there, and you can Google it. With Pi4j, you can write a code in minutes to either the bulb is on, the bulb is off, and you'll feel very happy and confident about the IoT curtain, which you might not be knowing what is happening behind the scene. So end of the day, you just try managing these pins, the voltage in these pins. There are sensors are being applied. For example, in my air conditioner, if Amitabh Bachchan is able to control my air conditioner, all these are couple of sensors which are taking input from you, and it becomes very easy. And if I go to my next screen, uh, what I'm trying to show you out here, you see how simple it is. Although this is not as simple as you think, but yeah, it gives you an idea that using my Java code, I can add a pin. I can have my pin state dot high and it would start blinking. I can make that thread sleep for 5 seconds and I can pin dot low. So we have these APIs inbuilt in Java which you can use in IoT. You do not have to worry much that, okay, I need to learn some different platform for an IoT, not at all. Although there are some beautiful service available over cloud now, which you can consume, but yes, IoT, you can see we can write a good Java code. Career opportunities in AI, ML, and big data. If I talk about AI and ML, these are buzzwords nowadays. And if you talk about any industry, we have very on war footing note, people are starting using AI and ML. Big data solutions, if you talk about any AI and ML algorithm, you can say the atomic thing is data. Data is a new fuel. And if you talk about any solution like Apache Hadoop, Spark, Kafka, Elasticsearch, Lucene, Cassandra, either they are written in Java or they are written for the JVM. So in the nutshell, if you are thinking upon embarking a big data or a data scientist sort of a technical profile, Java, its language, is gonna help you a lot, right? So everywhere you'll find such things. These are, I just collated. I know it's not be that legible to you. What I wanted to show out here, a lot of such libraries. If I talk about the very first library, just quickly, it's about the deep learning 4J. Lot of neural network, deep learning. We are trying to create models in AI and ML, for example, speech recognition, Alexa, Siri, Cortana. What we are doing eventually is we are training the models. The concept of training the neural networks is happening. The deep learning concept of machine learning, that is all happening. But let me not go into the details in the interest of time. But yeah, we have such APIs like deep learning 4J is there. We have something called Stanford Core NLP. NLP is for natural language processing, which is able to understand your voice, pitch, modulation, and such things are happening,
right? We have something called Smile, and it is all about data visualization. Such libraries are there. So for example, if there are data scientists out there, you'll able to make something outside of your data when you are able to visualize. So such things are there, and Java FX is there, which you can visualize. Even the NASA uses Java FX. We have something called Veka. Veka is a beautiful library where you can query that data and can make a lot of sense out of it. And I've just started it, Apache, Jena, Tweety, ECG23 and JGAP. Even I haven't used it, but this data is primarily taken from an Oracle, you can say, workshop. And definitely Java provides all these libraries in AI and ML. So a lot of trends of ML and AI and big data are there, and enterprise ubiquity, maintainability, performance, efficiency, scaling, visualization, serviceability, and support. So these are the fundamentals of ML and AI that people should be knowing about. And Java maps to each one of these, you can say, fundamental and trends beautifully. Talking about the enterprise ubiquity, I do not have to say much because more than 12 millions, or rather I would, developers are there, billions and billions of devices are there. So acceptance of Java, the availability of Java. For example, if I have an enterprise, I will not be interested to bring a newer language in my paradigm just to solve a very minuscule of my requirement, because I need to hire people as well in that domain. I do not know the certainty of that technology. I do not know who is going to support it, who's going to maintain it. Hence, I would like to bank upon a technology stack which is there in the market for years, right? And Java is definitely an enterprise solution. Maintainability. That's a beautiful thing. Maintainability. Whatever I have tried to show out here, let me try reading out. A developer goes to a project manager and says the project I inherited has weak code. I need to rewrite it from scratch. And this is generally happens for most of the developers. Whenever they are sitting on a system, they say XYZ person came. That person wrote something gibberish. I don't know. I'm not able to make or understand head or tail of it. Right? I'll be rewriting everything. That's what happens. And now the manager says, will there ever be an engineer who says that last guy did a great job? Let's keep all of it. How often it happens, right? And now the person says, I'm hoping the idiot you hire to replace me says that. So it is all about the maintainability of the code end of the day. You can't have a language in place 6 months down the line. If a person goes, the knowledge also goes, and that code becomes an outdated code. Will you be sustaining that model, or an enterprise be sustaining that model? The obvious answer is no. So coming to Java, it is a readable code. It is in existence for umpteen number of years now. You can read that code very well. The versatility of the code is there, and compatibility is n number of libraries. So maintainability point of view, it is very important. Although it's very easy, it looks like a very innocuous statement that we'll be able to maintain every other code. Believe me, that is not the thing. We are working on few products which uses legacy code base in COBOL. Right now we are in a situation that we are rewriting everything in from that COBOL to Java. Reason being, we are not able to maintain that COBOL code base. We do not have developers, right? No, we are not able to re-engineer new things. So we need to have a solution which is perennially available. And maintainability is definitely one such thing, whether it is AI, ML, or any such thing. Performance in AI, ML solutions, performance is very, you can say, an important thing we need to be wary of. And if you are comparing it with Python, Java is way ahead in terms of performance. This data is being taken by Debian Net, and it is one of the, you can say, a very highly rated organization in terms of matrix calculation. And Java, in terms of performance, it comes way above its peers and counterparts. So, yeah, performance is another criteria for AI ML based solutions. Density. When I talk about density, is the reducing memory footprints. So, what do you mean by memory footprint? So, whatever is my output, when I'm working in my AI, ML, and data solutioning, how much space is being taken by my, you can say, APIs, whatever solutions I'm creating. And since with Java, that footprints is definitely reduced a lot, the way the final output of the code is. Hence, Java is definitely, you can say, it takes much lesser space as compared to other languages. Scaling of my solution. If I'm working on any AI, ML, or big data solution, how quickly my solution can scale. Uh, JDK 11 onwards, I'm having some ZGC sort of a garbage collector framework in my Java that can scale, because that can do away with you can say my heap size in minutes. So I can scale from terabytes of data to petabytes of data in my AI ML based solutions. So this is the pace at which Java is evolving. Visualization of data. Any data scientist would like to visualize data. And if I give you this YouTube link below, please go and see this. This is a Java FX NASA solution, basically use Java FX. This screenshot is for, you can say, one of the, you can say, gadgets of NASA, which it is approaching a heavenly body, some planet, how the gravitational forces are showing the real-time data. So you can say the criticalness of the real-time data visualization is so critical, and NASA uses Java FX, my dear. So let's not even debate on, as you can say, APIs provided by Java, right? Now comes to a very interesting part of things, which is the role-based skill set mapping, which most of you might be interested in. This is how the current trends are there in market, because on a daily basis I'm taking interviews or meeting people, those who want to apply for jobs in Java or want to create uh, a Java as a career path. So this is, you can say, an assimilation or a quick summary of that. Java developer I take as a, you can say, a 0 to 2 years of experience. Why even the zero is included? We do have campus recruitees are there. What we look for, you can say, a must to have knowledge. Core Java and J2 is definitely must have languages. Some projects should have been created by those team members. At least one web framework, as we discussed earlier as well. We need web framework knowledge because that's how you might be required to work or code into. So knowledge of framework is very important, and basic database knowledge is definitely a plus, because I remember my very first project, I did not have a lot of knowledge about SQL, and I really was not able to write optimized queries, or my solution was taking a lot of time because I did not know a lot about foreign key constraints, the primary key concepts, how I can run my procedures, my functions. So knowledge of database is definitely an order add-on for a Java developer. Good to have design patterns, multi-threading. You, whatever you can add it to your skill set, that would be a good to have knowledge as a Java developer. Senior devs are generally 2 to 5 years. Don't quote me anywhere. These are not a sacrosanct, you can say, experience brackets. I have just tried to give, based on my experience, what I'm seeing in the industry these days. Senior Java devs 2 to 5, and you should be having idea about CI/CD pipeline, like which I talked about. DevOps knowledge is must to have, because this is an area where you would eventually be working on. Since once you code, if you want to see how your code is performing in the build phases, this is an important knowledge of Jenkins, Bamboo, Hudson. All these tools are important to have. Exposure to cloud. Without this, I don't think so you'll be able to write good solutions, and it is something which we should be having. Tech lead, 5 to 10 years of work ex. When we are accomplished as a Java dev, we have seen a lot of water under the bridge has already, you can say, has gone into. We need, we become a tech lead, and what exactly is required from a tech lead? I should be able to review the code of others. I should be able to mentor others. I should be knowing the design principles, philosophy of others. Why I'm writing a, you can say single class model is there. I have an open close principle is there. I have a substitution model is there. A lot of such things are there. As a tech lead, I should be knowing. I should be knowing how to optimize my code better. So if you're eyeing for a tech lead career path, you should be knowing all these things well. Solution architect is something which is basically a superset of everything. You should be knowing a lot about multi-cloud knowledge, because end of the day, you will be developing your solution for cloud. Your solution, it could be one of, if my client comes and says, hey Navengit, I want my solution to be a SaaS offering. And if a solution architect, he doesn't understand what SaaS is, like software as a service, I'll not be able to develop that solution. SaaS is software as a service is something like I'll not be hosting my solution in on-prem center for my customer. It would be a single location, and I'll be giving all my users the same solution. Like a service, your software would be served as a service. For example, email. You can say your, or rather Gmail is your software as a service. You open it, you are able to consume the services. Such type of solutions are very important. So knowledge of cloud is a must. Exposure to different patterns of architecture, it could be including microservices, it could be cloud, it could be security fundamentals. These are must for a solution architect. So this is at a high level. I have just tried to give you an idea about what are the role-based skill sets which are required in the market these days. Java versus Python. I know this is a talk or a question which comes to us every now and then. Although I come from a Java background, I have dabbled my, you can say, hands somewhere in Python as well. Python is definitely a language I started loving rather, because of its succinct and very less code you need to write. I'll try to be as neutral in my, you can say, comparison with Java and Python. So these are, you can say, a high level of you can say comparative way. I'll just quickly go through it, not go into the details. Type of programming language: compiled. Java is compiled and Python is interpreted. Because Java is a compiled, it is much faster. That's why in all the AI ML based type of solutions, it would definitely have an edge, right? Whenever we are doing any neural, you can say networking or deep learning, such things are happening, Java would be having, you can say, from performance point of view. Although Python has a huge set of libraries, it can do all those computations very easily. That's why it is language in recurring in data science. You can't beat Python there. Code readability. Code readability is definitely something which Python outscores Java heavily. Although I would like to show you on the next slide verbosity of Java code. On the left hand side, you see a Java 8 code. Okay, all of us must have written a very basic Pojo class, plain old Java object Pojo class in Java 8 on the left hand side. Number of lines are almost 15. With Java 14 onwards, the concept, or you can say a feature, has been added which are called records. Now it reduces the code from 15 to almost 8, right? So Java is also galloping with Python in terms of its verbosity. It is becoming less verbose. You can write code in less number of lines. So that's what I would like to, you can say, bring a perspective from the Java. In mobile app development, definitely we discussed it earlier, Java outperforms Python. Machine learning and data science, we have seen that Java has libraries. So it is something that Java is not monkey in machine learning and data science. We have libraries. If people are having Java background, they can make inroads in machine learning and data science as well. Learning curve. This is a very interesting point. Definitely learning curve is easy with Python because of its quick code, and you can see a lot of things are being developed, right, as compared to Java. Uh, so the verdict, which language to choose, right? Let me be, it depends on the use case, right? You can't have the same sword being used everywhere, and you can't win every war with the same set of weapons, right? That is a philosophy. So comparing Java and Python, I think it is a use case based. If you are working in uh, AI ML solutioning, we have beautiful libraries of TensorFlow and such things which integrate very well with Python. Go with uh, Python, right? Make sure you go for the right resources while learning either of the two, because that's going to make the difference between your liking or disliking it, right? What all things you have, what you already know, right? If you're just interested in programming and want to dip your feet in without going all the way, learn Python, for it's easier to learn syntax, right? There is, you can say, a bunch of people who just want quick gains out of things. Okay, let me learn something in 24 hours. There are courses available. Learn programming in 24 hours. And people do take those assignments because they just want to dabble in those areas. They do not want to go the whole hog of understanding the behind the curtains theory. So if that is the requirement, go for Python. If you plan to pursue computer science engineering, I would recommend Java first because it helps you understand the inner working of programming as well. Doing Python after Java would help you understand how it makes these things easier. Okay, so this is something which I really feel, if you know Java, you know the verbosity of a code, how things are written, how you can say a lot of multi-threading goes into it. You have toiled your nights into identifying an exception and all. So it's easier for you to switch from Java to Python and not vice versa, because then you will be spoiled. If you're writing code in Python, you will be spoiled to see very small code is being written and all such things are happening. Lot of such libraries are there. So my take is, if you know Java, you can somewhere down the line of your career, you can definitely go in Python, as I am doing. After 18 years, I'm getting an opportunity to work in these areas, and believe me, it is making me, since I know Java, I can relate to it and I can move to that domain very well. If you plan on making a mobile apps, then sorry, you have to stick with Java, because that's a lot of, you can say, technologies around Java. So that's my intake. And if you talk about growth, I think do not have to talk much growth in Java. After 18 years, we are of my career, I'm still getting an opportunity to represent Java and talk about it. Then I think it is not at all a debatable topic. We have growth everywhere in Java, as we have in other languages as well. So that was the content from my side. Pratibha, I'll just appreciate if you have questions or such things. Thank you, participant, for such a lovely audience.